No, I have to be careful myself. Ready? Hello, everyone. Welcome to the second series of the webinars from the Knowledge Hub of the Waterpipe Tobacco Smoking. This is Dr. Ghazi Zatari, the director of the Knowledge Hub, and we would like to welcome all the people who join us today to listen to our distinguished speaker. Our distinguished speaker is Dr. Professor Najat Saliba. Dr. Saliba is a full professor of chemistry at the Faculty of Arts and Sciences at the American University of Beirut. And she has an illustrious career that spanned over years. She's the director of the AUB Nature Conservation Center. And at the same time, she has been very instrumental in developing many innovative and original methods for analytical chemistry and for the characterization of waterpipe smoke, as well as the electronic nicotine delivery systems. Her work has been very instrumental in advancing the works of the Tobacco Laboratory Network, as well as other international organizations. In addition, she's a well-established scientist in the field of study of pollution, and her work also has contributed to many recognitions by international organizations. In addition to that, Dr. Saliba has received numerous awards. Most recently, she received the 2019 L'Oreal UNESCO International Award for Women in Science. In addition to her record, she's the recipient of the National Order of the Cedar from the President of the Lebanese Republic, the Honorary Cedar Shield from the Speaker of Parliament of Lebanon, the Lebanese National Council for Scientific Research Award in environmental category in 2016. It's really my pleasure to introduce Dr. Saliba, who is going to be talking today to us on the toxicant content, physical properties, and biological activities of waterpipe tobacco smoke and its tobacco-free alternatives. And it's a great pleasure to have Najat, and I will turn it over to her in a minute. Before I do that, I have just like a housekeeping issue. Just to bring to your attention, on your front page on the website, if you note to the bottom lower left side, there is a sign indicating the hand raise button. So please, if you need to unmute your PC, or if you have any verbal questions or comments, please press that button. This will give us the flag, and we'll be following up with you. You also have the ability to type in your question. This will be viewed by our coordinator, and the speaker will be more than happy to answer all your questions. Welcome to this session, and I'll turn it over to Dr. Saliba to inform us about this very important topic in waterpipe tobacco smoking.
Good afternoon, everybody. Hello. Hi. Okay, I'll be talking about waterpipe smoking this afternoon. So the title of my presentation is going to be the toxicant content, physical properties, and chemical properties of waterpipe tobacco smoke and its tobacco-free alternative. And like Dr. Ghazi Zatari said, I'm the director of the AUB Nature Conservation Center. I'm affiliated with the Center for the Study of Tobacco Products at Virginia Commonwealth University. I'm also a co-founder of CARS at AUB and the VMP at AUBMC. The outline of my presentation or of this webinar today is basically, I'm going to start with a set of questions to undiscover the myth related to waterpipe. We will also tackle some definitions so that we are all at the same page. We'll talk about the analytical procedures that are adopted for chemical analysis, and then we go on to talk about the toxicants. We'll discuss a little bit the research impact on regulation at the end, and we'll finalize with some recommendations. So the first question that I would like to ask is, what do you think about how old is water pipe smoking or water pipe? How old is it? Do you know who are the first people who introduced water pipe to the world? Is it the Chinese? Is it the Indian? Is it the Iranian or the Turkish people? In fact, it goes back all the way to China since 1150. And they say that there was a doctor in China who introduced this, thinking that the water would actually capture most of the smoke, and this would be a healthy way of smoking water or smoking tobacco. This has moved also to Iran, to the Persian culture, and also to the Turkish culture. And what makes the water pipe so popular? There is a lot of talk about this, but what's interesting is that at AUB, with the help of Dr. Shaya and co-workers, they were able to assess why the water pipe is popular among AUB students. And it was so interesting to see that 94% of AUB students think it's entertaining, and all above 70% think it's tasty and relaxing. What was also news to us is that 83% of these AUB students think it's okay to smoke water pipe in front of the parents, whereas they don't smoke cigarettes in front of them. So that was an important study that was really an eye-opening to us since 2004. And then, do you think water pipe is more popular among women or men? This goes back, it was so interesting to learn that there was a French painter who painted women sitting in palaces in France, also smoking water pipe. In a more recent study relatively, Dr. Maziak and co-workers found that 70% of the females think that the smoking water pipe is normal, whereas 27% of the male think the same. 33% of the male think the same way. So yes, at least in our region, people think that it's normal for females, for women to smoke water pipe. What's also interesting is that water pipe has become so widely spread, not necessarily in Lebanon, but all over the world. This picture was given to me by a student of mine who went to do her postdoctoral studies in Columbia University. And it was so a good discovery for her, actually, very interesting to her to see that there are students sitting outside campus and smoking water pipe. Also, there are so many hookah lounges that have identified cracks in the regulations and have been opening all over the world. This picture is taken in Redondo Beach, California, where hookah lounges have escaped the indoor cigarette smoking rules and laws and are opened. And I find a lot of them also in Europe. Last question is that what country do you think has the highest number of water pipe smoking in the Arab world? It was a bit surprising to us to see that Lebanon, Jordan, and West Bank rank among the top countries who have the prevalence of youth smoking water pipe. And this is a bit alarming considering all the other pollution stresses that people go and experience here in our part of the world. Okay, so now we go to the second part of the presentation is what are the parts of the water pipe? So we start with the head. On top of the head, there is the tobacco, and then come on top of it, there is the charcoal. Then we define the body of the water pipe, the hose, and the bowl, and inside the bowl comes the water. So later in my presentation, I will be using this terminology to refer to each of the parts of the water pipe. How does it work? How does smoking occur? So basically, the person inhales through the hose. But when the person does that, is actually drawing air in. So if you follow the air in on top of the figure, the air goes through the charcoal, lit charcoal, and then the charcoal burns the tobacco. As the air goes through the head of the water pipe, it's very hot. But then when it traverses and goes through the body, it starts cooling down. And as it cools down, it starts condensing. So the moment it reaches the top of the bowl, it's already condensed and the smoke starts forming. So if you can see here, the smoke starts forming way early before it even hits the water. So it bubbles through the water, but this smoke that was formed along the way does not have much time to stay in the water. So the residence time of the smoke inside the water is very small, probably less than a few seconds, and then it goes out to the inhaler, and this is what we say, this is what forms the mainstream smoke. So the mainstream smoke is basically the smoke that the person takes in and before exhaling it out to the environment. One important number here to remember is the temperature at which the tobacco burns. And it's around 450 degrees C. And if we were to compare this to cigarette burning, the cigarette burns at 900 degrees C, which means that the combustion or the pyrolysis. So the combustion in the case of the cigarette and the pyrolysis in the case of the water pipe are completely different. And as such, we cannot just compare tobacco burning between the two. That's why it becomes more challenging to see what are the chemical methods that we need to take in order to identify the toxicants coming from the water pipe in comparison to the cigarette. So in brief, what I'm trying to say, I cannot take what has been identified as toxicants in the cigarettes and just say it's an extension of what was identified in the cigarettes, and therefore I can directly deduce what we have in the ergile. And so, no, it's different, and that's why we had to do lots of research in order to identify the toxins coming from the water pipe. Before we identify the toxicants, we need to identify how we're gonna smoke the ergile. And in order to do this, we sent some of our researchers to the cafes in Beirut. And what they did, they registered the way people smoke water pipe. And they came up with an average smoking regimen. What do we mean by that? We found out that the total puff volume that the smoker uses is around 530 milliliter. And the puff frequency is 17 seconds. The duration is about 2.6 seconds. And the session, all duration is about an hour or 60 minutes. And the number of puff cycles in the 60 minutes is around 171 puffs. Most of the people load around 10 grams in the head, and they use around 5.8 grams of charcoal. The combination of all of these puffing parameters has been registered as the Beirut method. This method is developed or has been developed by Dr. Alan Shhadi, Dean Alan Shhadi, Dean of the Maroon Sem'an Faculty of Engineering and Agriculture, and he named it after Beirut, and it is now widely and internationally known as the Beirut method. Now, it was so crucial to actually standardize the smoking regimen. Otherwise, we will not be able to compare different methods and different smoking parameters from one lab to a second. So this is basically important to help regulators understand what they need to compare to what. So from now on, I will be referring to the Beirut method as the smoking method that we have adopted in all our testing methods. So after we have identified the smoking methodology, we needed somebody to smoke this. So this somebody is a robot that is also developed by the team of Dr. Alan Shhadi. And it's basically a robot that repeats one after the other, sessions after sessions, the same smoking regimen. Why is this so important? Because the robot that is referred to here as the smoking machine, once it's smoking, we are able to determine and we are able to collect through filters or other means the gases and the particles that are emitted from the mainstream smoke. Here you see that we collect the smoke from the hose. So this is basically what's getting inhaled by the smoker. Later, we found out that it's also important to understand the side stream smoke. The side stream smoke is defined as the smoke that is left in the room while the person is smoking. And so you can see here that we enclosed the water pipe inside a container that directs the smoke that comes out from the charcoal all the way to a room, and then from there we connected it to filters and gas collectors in order for us to do the analysis. So this setup is extremely important because it simulates what goes into the room and how it gets diluted before it can be measured. So for the rest of the presentation, I will be talking about mainstream smoke and also side stream smoke and differentiating between the chemicals in the two environments. Before I go into the levels, which I know you are excited to see, I wanted to stress on the analytical process and the steps that goes into identifying any of the chemicals that we do. So it starts with the sample collection, and in here it's basically how do we smoke the water pipe, and this is what I talked about through the Beirut method. And then anything that is collected, be it gases or particle, it's labeled. So there is a procedure on how we do the sample labeling and data logging. And then from there, there is also an optimized procedure for the sample storage. All of these should be taken in high consideration so that we ensure that we're not changing the quality and the quantity of the toxins before they are analyzed. Once this is optimized, then we can start by sample preparation and identification. We do the sample extraction. Why is this extremely important? So the sample preparation procedure is important depending on what we need to analyze. For example, if I want to analyze metal content, then I have to separate everything that is not metal from the metal matrix. So that's why sample extraction, sample preparation, sample filtration and purification, and then assessing the efficiency of this procedure is extremely important. Once this is optimized, then we go into a more sophisticated sample preparation method by using chromatographic techniques like high performance liquid chromatography or gas chromatography, depending on what analyte we want to analyze. And after that, the chromatographic method will allow a very accurate separation of the analytes that we want. And definitely, I am ending every time by assessing the efficiency of every step, because that's extremely important. There is a long procedure on quality control. So we have to make sure that everything we do is reproducible, repeatable, and it conforms to the standardized methods of analysis. So there is the calibration curve, there is the quality assurance, and the recovery. And then once we have the data, we do the sample analysis, we compare with what is available, because sometimes it's not available, then we recur to mathematical models to do the comparison, we do the reporting, and after the whole procedure is optimized, eventually we would like to turn this method into a standard operating procedure, because this will allow labs from across countries and across the world to compare notes and compare values. So let's start by identifying the physical and chemical properties of the raw materials in the water pipe system. So what do I mean by raw materials? I mean there is tobacco, and we said there are alternatives to tobacco. There is herbal products that they are claimed to be tobacco-free and healthy products. And there is the charcoal itself that could be a source of contaminants at the same as well. So identifying the toxicants in this raw material before even starting to burn this material is extremely important. And to do this, what are we talking about when we talk about physical properties? Physical properties include the type of tobacco, the mass, the type of flavors, the humectants, because you can see that a lot of tobacco, they have glycerin, they have propylene glycol inside of them. There is a certain amount of water, so wetness is extremely important. And the packing density is a factor that will also either restrict or allow more air to go through the head of the water pipe. In the chemical composition, I will only talk, due to the limited amount of time, obviously, I will talk about two components, three in fact, polycyclic aromatic hydrocarbons for their extreme importance, and I will get to that later. The metal content also because they're extremely important and carcinogenic. It's a carcinogenic. And then I will briefly mention nicotine and aldehydes. So if we look at the physical components of tobacco, for example, there are all sorts of tobacco and all brand of tobacco that comes with sweeteners. They come with high levels of glycerin. So the market is full of that. There is the wetness and the way you pack the head, and there is the charcoal. Again, for the limited amount of time, I'm just gonna walk you through the process that we take in order to identify one of the toxicants in the charcoal. So polycyclic aromatic hydrocarbons are usually produced from incomplete combustion. They are extremely important because some of them are very toxic. Benzo, for example, is classified as type 1A carcinogen by IARC-WHO, the International Agency for Research in Cancer at the World Health Organization. And they are mostly, because they come from incomplete combustion, they are expected to be present in high quantity in charcoal. Now, if you can see here, we have listed 16 polycyclic aromatic hydrocarbon. Why 16? It's because the Environmental Protection Agency at in the US have identified those 16 are the most dangerous. But you know, when there is an incomplete combustion, there are more than 100 different polycyclic aromatic hydrocarbons. So from now on, I will be only talking about 16 of them. And in some cases, I will stress a lot about the presence of benzoapyrene and do some comparison with the cigarettes in terms of benzoapyrene. So in terms of the sample preparation procedure, so we take the filter that we collect from the mainstream or the side stream smoke, we put it in in toluene in this case, but we put it in an appropriate solvent. Toluene in this case, because the polycyclic aromatic hydrocarbons are not are non-polar, and so we chose a solvent that is non-polar. And then we put it in the filter, we sonicate it for a certain time. We remove the filter, we hope the polycyclic aromatic hydrocarbon have transferred into the solution. And because they are present in small quantity, what we do, we tend to concentrate it by evaporating some of the liquid that we have added at the beginning. After that, we even do a better separation by doing solid phase extraction and trying to isolate the polycyclic aromatic hydrocarbon from the rest of the contaminants that are present. And we do this by using a certain solid phase extraction cartridge. And then from there, what we do, once we have isolated the polycyclic aromatic hydrocarbons, we put them on gas chromatography mass spectrometer tool or machine, and we do the analysis. Usually the analysis is done in two ways. We look at the chromatographic peak in comparison to standards, and we also look at the mass spec fragmentation. And we do the quantification also using the two methods. Because we have a GC coupled to mass spectrometer, that means we look at the peak and we compare it to a known value of the standard, and then we make sure that this peak is not overlapping with any other peak, by making sure that the fragments, that the composition of this compound comply very well with with benzoapyrene, for example, or other PAHs. So this is part of the quality control that we do. Once we do that, this table is extremely important because you have to look at whether the method that you adopted is repeatable from 1 day to a second, from one sample to a second. The recovery means how much after the extraction procedure is done, how much you are able to recuperate from your original sample. And usually it varies depending on the sample, but with polycyclic aromatic hydrocarbons, this method that we adopt is very good. Limit of detection is very function of the machine that you're using. And in here, we can go as low as 0.01 microgram per milliliter, which is very good. It's like about 10 ppb. And then the limit of quantification is usually a factor of the limit of detection. And the correlation means the calibration curve that you draw within a span of concentrations is very good. They are all correlated to each other. I'm sorry, I thought some of you would be technical, and that's why I'm going a little bit deeper into the technicality. I will answer your questions if you have more questions about these later. So when we looked at the raw charcoal, what we did is we took a walk along the corniche here in Lebanon, meaning that it's a place where we have lots of cafes that they offer water pipe smoking, collected the charcoal randomly from the cafes. We brought them all to the lab, and we also mixed them together and randomly picked samples. Okay, this is for the lump. I mean, this procedure was taken for the lump because it's the most popular way of lighting the water pipe in our case. The Three Kings is a very popular brand that is sold in Lebanon. And what was interesting is that the Coconara is another brand that is advertised as a healthy charcoal. And that is the name Coconara. Coco means from the coconuts. And they say it's herbal, that should be healthy. And then we measured the polycyclic aromatic hydrocarbons on those 3 samples. And to our surprise, we found that the Coconara has the highest amount or the highest nanogram per gram of charcoal of polycyclic aromatic hydrocarbon. And the lump, the traditional charcoal, is basically exhibiting the lowest amount of polycyclic aromatic hydrocarbons. Why is this interesting? Because now we're saying that before we even light the water pipe, before we even do anything, just get the charcoal and crush it. and measure the polycyclic aromatic hydrocarbon, you get a substantial amount. So now imagine if you put this charcoal on top of, you burn it first of all, and you put it on top of the tobacco. So what will happen is that this charcoal, while burning, all these polycyclic aromatic hydrocarbons are either going to go into the room where you're smoking, or they're gonna go through the air, through the tobacco, and then pick up with, get mixed with the smoke and form what we call the mainstream smoke. And you will see in the mainstream smoke that we have a lot of polycyclic aromatic hydrocarbon. So getting to the mainstream smoke, in fact, it's the smoke that comes out from the hose, and we have tested it for burned tobacco products. That means in the head, we have stuffed it with tobacco products. We also used non-tobacco containing herbal products, and we just removed the tobacco completely and we put the burnt charcoal on its own. And this slide shows how, the different studies by different people all across the world who determine the amount of charcoal that comes out from the water pipe during smoking, the mainstream smoke of different tobacco products. And you can see that there is a lot of, the levels of polycyclic aromatic hydrocarbon can exceed the 5,000 nanogram per session in the mainstream smoke. What was also very interesting is that when we use herbal products, non-tobacco containing products, but herbal products, we also found lots of polycyclic aromatic hydrocarbons. And in one of the study, the amount was 18,000 nanogram per session, as compared to the previous slide, where we found the highest amount to be 5,000 nanogram per second. So this so-called healthy water pipe, in terms of polycyclic aromatic hydrocarbon, we don't believe it's that healthy. Looking at burnt charcoal alone, look how much we found. In one of the studies, the amount was astonishing, okay? We cannot compare this number to the previous ones, because here we're reporting in nanogram per session, whereas here we're reporting in nanogram per gram. Nonetheless, the amount is very, very high, and we know why. Because we said the charcoal, by a natural process, they are formed by incomplete combustion, and incomplete combustion would automatically form lots of polycyclic aromatic hydrocarbon. Looking at the side stream smoke, what do we mean by side stream smoke? Again, it's the smoke that comes out from the head, and it's basically the smoke that your partner or your colleague or your kid, if you're smoking in front of a kid, will be inhaling when you are smoking a water pipe. And in here, we also tested the two types, the burned tobacco products and the herbal, the so-called, and I keep saying the so-called healthy products, because we didn't find them as healthy. And so the polycyclic aromatic hydrocarbons in side stream smoke were high. We found around 400 nanogram per session as a high value for one of the polycyclic aromatic hydrocarbons. And for the tobacco-free products or the herbal products, the level were as high. So it didn't matter whether it's a tobacco-free or not. The levels were very high in the side stream smoke. So this is a summary of what we found for raw and burned charcoal, and you can see that the different studies and the different charcoal types have reported different levels of benzoapyrene, and here we're only reporting the type 1A carcinogen, the most toxic polycyclic aromatic hydrocarbon, the benzoapyrene. And you can see that the levels from raw charcoal and from burnt charcoal are very high. Now they depend, they vary from one type of charcoal to another, but they're still not negligible, I would say. Looking at benzoapyrene in the smoke, in the mainstream and side stream smoke, you can see it's all over the place, especially for the burned tobacco. Now, for the tobacco-free, it's also substantial. In the side stream smoke, the red numbers, it's as high as in the mainstream. So it really didn't matter. Now, if you want to compare to a pack of cigarettes, you can see that in the side stream, the pack of cigarette, the square here, is much higher than what you see for the water pipe. But in the blue box right here, if you compare to cigarette, you are inhaling as much benzoapyrene as you are inhaling in a pack of cigarette. So in a nutshell, if I want you to remember one thing when you leave this webinar is that the main, if you are sitting and having a water pipe session, it is equivalent to 2 packs of cigarettes in terms of benzoapyrene. So one session of water pipe is 2 packs of cigarettes. And if somebody is sitting next to you, just entertaining the conversation, he or she will be inhaling or will be smoking what is equivalent to 4 cigarettes in terms of benzoapyrene. The aldehydes are a totally different story. Why? Because the aldehydes are usually coming from the sugar that is added to the water pipe. Usually the breakdown of the aldehydes makes the breakdown of the sugar makes the aldehyde. And the most notorious one is the formaldehyde. The formaldehyde, at a high concentration, it's deadly. At a low concentration, it causes sore throat, cough, eye irritation, and nosebleed. So it was very interesting actually to measure the aldehydes. Also, I would like to add that acetaldehyde has been shown to react synergistically with nicotine to increase addiction. So there is this myth about water pipe that it's not addictive. We have seen that we have high levels of nicotine and also high levels of acetaldehyde, and you can see here that the red box referring to the cigarette is much lower than what we saw in water pipe. And so the addiction here is worse than what we saw in the cigarette. So I want to also talk about other toxicants like total particulate matter, CO, tar, and nicotine. So if you remember, we said for benzoapyrene, it's equivalent to 2 packs of cigarette. For aldehyde, the aldehyde that we measured in water pipe, and I'm talking here mainstream smoke, it's equivalent to 5 cigarettes. The carbon monoxide that we measured in water pipe is equivalent to 2 packs of cigarettes. The tar, and it's so interesting, we did once an experiment where we didn't put water, we just wanted to see what the tar does, and it was dripping like yellow, viscous, very sticky material that was dripping inside the bowl. So the tar that is mixed with the smoke or mixed with the water, mixed with the smoke here, is equivalent to 3 packs of cigarettes. And in terms of nicotine, it will be like if you're smoking 3 cigarettes. Last but not least is the total particulate matter. And here, I'm not talking about one particular size, because you know that the particulate matter of 2.5 micrometer in diameter is very bad, is very toxic. Here we measured the total particulate matter that could be higher or lower than PM 2.5, and it amounts to 7 packs of cigarettes. Is this enough? Maybe it is. Okay, so let's talk about one more thing before we conclude. I think I want to talk about the metal very, very briefly. But when you talk about metals, you have to think about many different sources for the metals in the water pipe system. So charcoal is a source of metal. The aluminum foil that you put on top of the tobacco is also a source of metals. There is the body surface, the hose connectors, and there is the bowl if it was metal and not a glass. And so all these metals can contribute to the metal content into the mainstream and the side stream. And so what we found in the unburned tobacco products, just did the tobacco products on their own, and we found lots of manganese and aluminum. But that's not the problem. The problem is in this small insert that you see in this figure. It's the nickel, the chromium, and the lead and the cadmium, which are very toxic. Same thing for the charcoal. We found heavy metals like nickel, chromium, and lead in large quantities, and this is very alarming. I'm going fast here because I think we have to wrap up. If you can see, I mean, there is arsenic, nickel, chromium, and lead in the water pipe smoke, in the raw charcoal, in the burnt charcoal. Some of these metals are considered group 1 carcinogen by IARC, and some of them are considered group 2, and this is extremely dangerous. I think the metals are another beast altogether. Even the burnt tobacco has shown this, so I'm gonna skip this, and I wanna say at the end, so it's very important. I mean, we did a lot of work and we compared notes with other laboratory, and we found that we can get to a place where we can standardize many of these factors, many of these variables, to come to a common ground and be able to compare note across labs. And this is important because it helps regulatory, policymakers to actually implement laws, and it helps also governments to put some regulations on imported content like tobacco and charcoal. There is a lot more to do on the hazardous emissions of tobacco. I am sure this is not something that will end soon, because also the market is varying and the shapes and the forms are varying. We have identified several type 1A and group 2B carcinogens that are really alarming. Also, in terms of the metals, it's very dangerous, and we would like to invite everyone to get on to do more work on water pipe and understand more the effect of water pipe on the health. So I would like to mention at the end that most of our work has been adopted by the World Health Organization, by the American Lung Association, and last but not least, by the Lebanese government. So there is in Lebanon Law 174 that bans smoking water pipe or else, I mean cigarettes, indoor. Unfortunately, this law was implemented only for a few months, and we still have a long battle in order to make it a law and implemented and respected by others. And I thank you so much for your attention.
Thank you, Dr. Saliba, for this presentation. Now we open for attendees to ask any question. You can type in your question in the question panel, or you can press the raise your hand button and we can unmute you so that you can ask the question.
Mama, put it on. Okay. Huda is asking about the difference in PAHs when produced at 350 degrees and that produced at 900 degrees. When PAHs are produced, they are produced. I mean, there is no difference in the chemical composition, but the lower the temperature, the more PAHs are produced, because this will make the combustion incomplete and it will form more PAHs. So it's not in the PAH themselves, but it's actually in the amount that is produced at low burning versus high burning. I mean, it's side effects. No, it's the same. It's the same PAH. I mean, if we're talking benzoapyrene, it will be benzoapyrene. To develop new chemistry lab methods for these already standard for tobacco research. We are working, so I'm talking about the standards, the new methods for analyzing toxicants. We have been working with TOBLabNet. TOBLabNet is basically a lab at WHO to recommend standard operating procedures for measuring toxicants in water pipe and in electronic cigarettes. We have been working with them to actually disseminate standard operating procedures for the major toxicants that are determined in water pipe. Up until now, I think we have standardized we have standardized nicotine in the content of tobacco. And I'm stressing here about the content and not the mainstream smoke, because what we found is that there are so many variables in the mainstream smoke, like the length of the body, the amount of tobacco that is used, the smoking regimen that can change, the volume of water that is used. So all of these factors come into play in affecting the concentration of the toxicants. And work is in progress now to actually work on one standard method in order for us to be able to standardize the analysis of the toxicants. I hope I answered your question. If you have measured the I was wondering if you have measured the existing toxicants, chemicals in various flavors versus non-flavored tobacco that are in the market in EMRs mostly. I agree. The flavoring is a very challenging task. Let me tell you a little bit about what we're doing with electronic cigarettes. The flavors are the flavors. When they burn, they mostly produce aldehydes. And that's why we were targeting aldehydes before anything else. Now, when it comes to flavors, it's very difficult to go into each of these flavors because there are more than 10,000 different flavors in the market. And so some of these flavors are actually used in food and in the culinary industry. So on their own, they might not cause harm, but what is harmful is when they burn along with the charcoal and others. And that's why we thought about the aldehydes. So the aldehydes are a product of flavor burning, and it's justified. We are in the process of identifying other products that could be coming from flavors. I can give you another example, like if you take vanillin, for example. Vanillin is highly used in the flavoring, in flavoring tobacco, and one of the products of vanillin combustion could be benzene. Benzene is also another major toxicant. There is a group in Germany, I think, that they have identified benzene in tobacco, in water pipe. Now, benzene also can come from tobacco burning as well.
You are.
Sorry, Valley, I can't hear you. Other questions?
Thank you. Just a good discussion.